Or as opposed to we're live. Cool. So double check we're live. Yep. Lovely. So last stream, what we got done was kind of like this moss material thing. So yeah, it just looks like this, right? It's a cube which we ray march into. There's 3 spheres which are smoothed together, and then we just apply noise on top, and voila, we get this. So one thing I did today is doing grass because, well, it just popped to mind, and it would be nice to get some something, some other organic thing, if you will, as rendered. But yeah, so I think we're just going to explore doing a bunch of different materials or different ways materials can be applied and sort of figure out, like, make sure this material system that we're building makes sense. And then afterwards we'll do a mesh system when we've got a bunch of these different materials. We're just sort of trying to make sure that everything sort of makes sense together, basically, before we build it up a bit too much. But yeah, so a quick prayer and then we'll get going. I'll leave it there. Right. Father in heaven, thank you, Lord, for this day. We bless your holy name. Thank you for giving us another day to your will, another day to live on this earth, and yeah, another day to spend more time with our family while we're all still here on this planet. Thank you, Lord God. We bless your holy name. Yeah, help give me the insight and the knowledge to find the right answer to go down, the right path to go down, and find the right answers, and yeah, just help this stream go smoothly and well. And I pray that all the viewers will have a good time hanging around, but also learn some things. And I pray for each and everyone who pops by that their hearts be softened to you, Lord God, and you draw them in. And if there's any problems that people are going through in their life, Lord, I pray you attend to their needs. Thank you, Lord. In Jesus' name we pray. Amen. Cool. So, quick little bit of research time before we get going. There's different ways we can do grass rendering. With different benefits. So, I guess we'll make a new document. We're just going to open up in the docs. We'll call it grass plan. .md. So we've got different methods, right? Method 1, which would be, let's leave this running because it does kind of look all right. I'm quite happy with how the moss turned out. It can definitely be better, but it's a good first stab. So one method of grass would be we continue with the method that we're doing where we're just putting boxes down and we just somehow ray trace or ray march into the ray march into a volume, right? A 3D volume somehow, right? Maybe you can, right? So maybe you can leverage, like, I don't know, like could be, maybe you can, like ray march like a height field or something. I don't know, something like that. Like procedural. The pros is like if we were to have a volume of grass that's just placed down, um, then it could handle, LOD inside the rain marcher, right? And just sort of exit early and, just display some sort of, yeah, kind of, you can do something like that in the shader. But I think a con might be how do you've got to somehow like get um like say if you were to have a volume, you have a landscape. Do. And for some reason you just want grass. Right, you want grass to be all over this area. But you kind of want the other problem with these volumes is you want to sort of like place them in such ways. Yeah, so the other thing with placing these volumes is like you don't want to place it like that. Because if not, then it's gonna do like a whole big old. But then you could also just have a custom mesh which sort of just sits above the surface, right? And you're only remarching into that type of thing, and that's where the grass lives. Ba-ba-ba-ba-ba. So, um, yeah, you'd have to have custom meshes that sort of fit the volume nicely and stuff like that, and then you remarch in them. So you could do that, right? So let's write that down in here. Custom mesh to fit the terrain. To fit the terrain heights, basically. Right, so it just goes. So how this knows where the ground is that it's fitting the height, and then that means it could do the hills as well at an angle, because in material space this will just be going along the x-axis, right, type of thing. That's all it will be doing. So you could do it that way, right? And then it can kind of do the LOD thing. You'd have to make sure the mesh doesn't LOD and then start cutting the grass out. But you could do like the LOD and the ray marcher, so you can take an average of the yeah. Maybe. I don't know if that's really a pro to handle it in there, but it's there. So a con would be so you can't handle different types of grass. So yeah, you might be able to. So say if you want to have different blades of grass, you could obviously take a hash of the and yeah, you could probably take a hash of this position and randomize between a bunch of stuff and be like, boom, that's the type of grass blade we're using. But yeah, so the cons are going to probably be so randomize the type of grass blade between a select few per volume, something like that. So the con is like if you want to say, hey, I don't want grass here, but I want grass like everywhere else, then how do you do that? Right? Because it's like a material, oh, this would be a material space or whatever it will be in. So you'd have to somehow per pixel like evaluate zones of grass and no grass. Like, am I inside these zones where they want grass and not grass? right? So you would have probably zones of. So it wouldn't be a case of like placing it down with a brush at this point. It would be placing down these zones which go. Yeah. Um, yeah, so you'd be placing down. Oh my god, this is all over it. Bring it over it. So place down zones. Like maybe spheres or ellipsoids. It can be rounded, right? Say ellipsoid. Zones to add or remove grass. And so these zones will have to be evaluated per kind of as you're ray marching through the zone. And also zones will have to be, you'd have to sort of store these as well. Stored and passed up to the GPU. You know, it's just more code basically. More code slash systems to write and maintain. What else would you need? You could probably have different zones with like, you know, maybe I want some certain types of flowers and things. Oh, at the end of the day, this is probably just a material. Uh, yeah, you could probably have a custom material uh, thing there. But the other pro about this is in the layer system, in the render layering system that we have 4 layers of rendering. So a mesh, which one is it? Is it the depth? Maybe is a good one to look at. So if you see here, here you go. Cool. I don't know what's going on there because that alpha's probably 0. So notice here how this moss, it's actually just a cube, right? And yeah, that's all it is. And then um and then obviously on the second layer, this cube wouldn't be the cube which the moss is being rendered. It's actually the background behind it, right? It's the thing behind it, but it's just cut out in the shape of a cube, effectively. Okay. So we've got each one of these RGBs and A's of 4 different layers, and we do this such that we can, if we miss ray march in this shape, we can do something behind, but also order independent transparency. So the pros of doing a volume is it works well, right? The whole grass is one render layer, right? All together uh, as a group. So all those tons of blades of grass don't get evaluated when we render out the meshes at all. It's just one mesh basically drawing that in. And this means that we could, I guess the pro of that would be, they're going to be opaque anyway. It's per pixel layering. So, you know, the only benefit is if we want to, make it transparent. And see the stuff behind it. I don't think it really matters that much as I'm writing it out now. I'm seeing it. But it's good to write it down at least, all the pros and cons, even if they're small and right. But yes, that's interesting. What other pros and cons have we got with this system? It de- if you, so you could do like a height field or something, maybe. I've got to research some more into that. B, you could have, so your materials would be, it'd be quite difficult to say I want these specific ones here or a bigger set here and that without, you'll need zones basically. Right, so zones, place down zones to add, remove, uh, you know, change thickness maybe, or thickness or material. To modify the grass basically in some way. I can add, remove and all that. So yeah, the zones have to be processed, right, which maybe requires some kind of acceleration structure. Zones will require some kind of acceleration structure, maybe. Grid, maybe, right? It's just more systems, right? To write and maintain. I think that's method one pretty much ironed out. The other method would be the method two would be, we just render little meshes basically, right? Render effectively quads, well, not really quads, but probably, probably boxes or essentially rendering a box with a few more vertices such that it can bend. And so if we were to draw that, we would probably draw some kind of, it will be something like ding, ding. Maybe it's skinned, but you get away with probably like 4, 2, 3, 4. Did Ghost of Tsushima, how'd you ever pronounce that name? I think they did this thing. They did a GDC on it some times ago. Procedural grass. Right, let's just get a summary of it. Well, when you ask a summary from AI, it's like usually an essay. But anyways. Entirely on the GPU. Whoa. This system allows for hundreds of thousands of individual blades. What? Animated simultaneously. Per blade procedural generation. Instead of artist model meshes, the engine builds each blade with Bezier curves. Woo. This allows for developers to adjust the height, width, and tilt on the fly. CPU instancing. The CPU sends a single blade to the GPU, which it then duplicates millions of times across the landscape. Compute shaders. I'm struggling to understand what that means exactly, because it seems like it's dynamically procedurally done, but then they only do one model. So I think maybe that just means there's just a bounding volume, and that's just used once. But then the Bezier curve goes inside that bounding volume, right? It's adjustable. Just ask AI to explain in caveman language and paragraphs. Yeah. Yeah, maybe it is clearer. Yeah. The every time or yeah, when I'm a bit more uh I didn't do it all the time up front, but sometimes I'll write something to AI and it does something long and I'm like, short please. Afterwards, and it does it again. But yeah. So I'll look at the video in a bit. It's a bit longer. This will be more digestible. I remember watching it before. But yeah, luckily it's only 26 minutes. I think we can skim through it. Yeah, I think they have diagrams too. So compute shaders, heavy lifting by calculating position, random offset, and individual animation for every single blade in parallel. Right. Near field, higher detail blades, 15 vertices. Right. Low detail version 7 vertices, save resources. Far field, individual blades are replaced by an artist authored painterly textures to maintain the horizon look without performance hit. Cool. So that seems to make sense. Usually you need to do stuff like this. Right, wind and stuff, we can worry about that later. Yeah, we'll look at the video in a sec. Curved normals make flat blades look rounded and thick without adding more geometry. Wow, revolutionary. The game uses curved normals to manipulate how lighting hits the surface. Cool. View space, thickening. Are perfectly thin when orthogonal to the camera, right? But why does everyone want a thick grass blade? All right. Blade folding. Short grass density is artificially increased by folding single blades in the middle to look like two blades. Huh. And no, it's rendering costs. Hang on. Short grass density is artificially increased by folding short blades in the middle. Oh, okay. So it's basically making it like a 90-degree angle in it, I imagine. Cool. Yeah, so this one, you would basically call it meshes, basically, right? So anyway, let's just quickly look at some detail. LLM has no concept of long or short. Maybe start explaining 100 words is better than saying make it short. To be honest, that's human beings have the same thing, right? What does short mean? But yeah, like short for me would be a paragraph. But it varies. If you're asking for like 3 things. But yeah. Yeah, say conservative. Yeah, speak its language. Conservative tokens. I like how LLMs guess up the most basic thing in like it's revolutionary. Yeah.
You can fairly clearly see
Yeah, it's like
the texels of the texture that control the grass type.
yeah, they're very good at selling their existence, you know? That's what they got to that's their role, right? This is 1080p apparently. And you're watching even worse quality than I am.
This gives us a smoother dither
Come on, give
transition
me.
if we just did a point sample.
Come on.
which is
Right, there we
important for
go.
making it less obvious that we're
Right, let's
targeting
close this. I
frames
like
with the
having my
low
thing
exposure
rendering in the
texture.
background, but we gotta. Right, what was this funky? Right, here's the
A rather expensive one. Instead, we slightly outward a bit. This helps
right, it's the rounded normals.
the U dimension of the
Yeah, so all
texture
it's doing is just doing a
control doesn't
flat
clump the grass occlusion
plane,
wind area,
basically,
since wind speed and direction
kind
will
of
be
thing.
changing.
Not a
You
plane, but you know
also
what I mean,
need
like
to
a
have a
flat
displacement buffer for
quad,
last frame in case a player
different.
was walking over this grass. And since a lot of wind and
Yeah, we could do
displacement
stuff
information
like
processed in the
this.
compute shader, we'd need to store the process data
It
per
would
blade for the vertex shaders to consume.
would
Also, we
look
procedurally
nice.
place full artist-authored assets throughout the fields. This lets us, if we had just stubbed in the random red spotter lilies would have flooded out the green.
I wonder how it fits
We
in
also
with our
made
system, though.
some
That's the
special
problem. You know what I
optimizations
mean? I don't want to just be like being a hodgepodge of different things. It's got to be like a family, like a cohesive set of features. But yeah, here's the yeah. It's just a bunch of little quads stringed together on a spline type of thing, and there's probably some sliders they can drag to do this. You know, that kind of fits in with the mentality in a way with what I want it sort of be like an ergonomic thing. But I'm wondering if what I want is there's different blades that you've pre-configured, if you will, and you can sort of like brush it down, maybe. There's stuff to think about.
This means their grass blades are spread out twice as far. To make this seamless,
The positive basis in allows a part of the hallucination problems. Yeah. I think if it was less helpful.
Normally, all of our verts are spent on a single blade. What if the grass is short enough?
Right.
We fold the verts to form two blades instead. This is one of the great ideas we got from Altera.
Yeah.
Really helps
like sometimes I've asked AI stuff, and you would see it's like, you know, the other day I was talking about the grass stuff because I was researching, and it was telling me how to do some of the grass things, and I was like, yeah, but if you did it that way, you're if you ray trace it from different angles, it's going to be a problem. And it was like, you're absolutely right. I was like, like, why did you just make something up on the spot? See, you have to be super careful with AI stuff. Code bases these days can be so like polluted with crap because people just copied it. You know, I've probably copied some stuff I shouldn't have, not going to lie. I'm not completely free of that. But there've been small little utility things. Obviously, some of it's the bread and butter, but I gotta you gotta double check all that stuff you do. But there's only a few things I've done it with. Other times I've traced down where it got it from and copied it from the actual source, and then got the copyright in there as well. You know, oh, this is MIT or whatever.
What if the grass is short enough? We fold the
Yeah. Yeah, that's the thing. You need to help. Yeah, you need to kind of know sometimes what you're researching into. That's why you need to like cross-reference it. You get something from AI. But it's great at giving you 90%, right? You know, because Google search is terrible these days. You can at least sort of get access to the language in what to search for and understand. But yeah, you just can't believe it 100%, obviously. But yeah, so there's a Bezier curve thing, but it's in the Bezier to the vertices. So it's not doing it to the.
But how do we make it move?
Yeah, it's in the Bezier to the vertices.
We decided early on that we wanted.
And where's the far stuff? Can we see far?
Combined with our wind direction vector to use as an input to our various systems. So that's how we rendered huge fields of grass within our frame budget and met our art direction. Assassinate Mongols. And
so there's some far ones over there. I can't really tell exactly where they mention that.
To access on CPU. Whenever we load a tile, latency is fairly low at the base of the grass blade.
So
And reduces towards
yeah, this is giving us some ideas.
AO functions the same. being darker near the
Gloss 1D
base, where the light is likely to
texture.
be excluded by other grass blades, and lighter towards the tip. The grass blade belongs to, rather than each individual thing we reduce gloss. So we have our grass blades and their verts.
Pixel shader.
Now we just have to shade those triangles. That's the high. For grass in some particle systems, we do an additional layer of Perlin noise to get more
Kind of
complex
cool.
motion.
Yes, there's the
Now,
wind
to know
stuff.
more about our wind,
You know, I wonder
hear my
where.
colleague Bill Rockenbeck's talk. Section is a bit of a grab bag of things that help pull the whole system
Data
together in an actual
pipeline,
production
computer shader,
engine.
pixel shader,
So the
MISC.
type of grass it is, which determines acid
Oh, what's that?
parameters and our
That's
different
information. Generating 3 positions, 1 face. Tilblet, grass type. Seven LODs. So yeah, there's the 7 LODs for close up, wasn't it? Sorry, for far away, I think it was. Oh, and then they did the blending, whereas there's the tilt thing. Yeah, maybe we'll ask the AI again. But yeah, I think this has given me an idea of what they do.
grass, but
Yeah, I wonder if they talk about this sort of
generate.
village as well.
Artist-driven assets support, especially when combined with being able to grow for a couple of years.
And then the people. Right. So if I were... So the far field, individual blades are replaced by artist-authored painterly textures. Okay. Right. Cool. Yeah, Google search got far worse. Yeah, exactly. When I was a teenager, well, teens have no memory of when it was good. Yeah, when I was younger, like half my life ago, Google search was great. Literally the first few clicks. Obviously, sometimes you'll go through many pages just to try and find some stuff which is a bit more obscure, but for a lot of the time, you would find what you want. Now these days, it's so difficult. They just try and give you the sort of the pop culture result, if you will. The secret was to render less the further you are based on average blading of grass in a grid area, and bend the grass to hide the bald spots. What do you mean by bald spots? But yeah, you bend the... Yeah, because obviously it's kind of flat, right? So... Yeah, I'm not sure what you mean by the bald spot, though. Yeah, maybe the AI would know. No, probably won't. Cool. So I got some ideas, right? So there's, render like grass blade meshes. Now this can work in different ways, right? You can obviously have the ghost way, but I want to explore what is the sort of, the hero's engine way, right? Because you could have the way we're doing things is like we're kind of doing volumes of meshes that we ray march into. And I wonder if we should be doing that, because then it fits in with the material system. It's like, well, now I can paint down like some grass here with this brush of material, this thing, and then voila. So I think that might be the better way to go. But yeah, so you would only need... Well, the best way depends on your art style. Yeah, exactly. Yup. Maybe you don't want grass at all. Yeah. Maybe you just want a flat texture that's blurry as, it's very blurry, so it looks like a PS1. Those days, though, the floor looked horrible. Those very low resolution textures. Okay, so I was thinking maybe what we could do is have... So they had like 15 vertices, and they would have it controllable up to a spline of so many. Let's see if we can figure it out. They had it somewhere around here. So 1, 2, 3, 4, 5, 6, 7, and then a tip. Obviously, that tip was controllable. While I'm playing a game, looking at the floor. Well, as an artist, you look where you shouldn't be looking. But yeah. So, it's a bit like when they have the depth of field which comes on. Like, so here, I'm looking in the background. Why are you blurring it for me? Force me to look at the player. So if we did like a box, obviously that's like 4 times the amount of vertices. Obviously the back ones get cold. But yes, they could have different rotations and things, and then you could, but then, yeah, you see, what they didn't really answer is they also have plants, right? Obviously, they're probably doing those differently then. Like, they've got these grasses with like these things on the end as well. I don't know if they really mentioned what that was. Maybe that's not grass. But yeah, they've got these things as well. Like, do you call them ferns? Not sure what the technical term is. I don't garden.
Procedural grass field assets that the growth systems use.
There are blur as well. Yeah, to be fair, in real life, life is a blur for me because I need glasses anything further than arm's reach, you know. Yeah, plants they said was an artist support assets. Right, so they just added things
We keep the nearest 3x3
on
tiles to
top.
the
Right,
camera in
okay.
memory and drop anything out of
Yeah,
that
so I was thinking about
material.
maybe leaning into the full arts driven way anyway, if you will. So that would be, maybe it's just a segmented cuboid. There's not really a cube then, is it? But it's like a 3D segment. You call it a spline, would you just call it? So 3D spline is kind of like a box spline. So you just place those down and then, each. So obviously it's kind of skinned in some way. Up to 6, maybe 4, but we'll see. Up to 4 or 6 segments. And then so so a blade. Let's write the language. A blade will be a 3D box. Cool. So each blade has a material. Has a material, has a material, has a material, like a thickness at the top and bottom. You also might want to spawn things on the end of the blade as well, because it's this could turn into like a plant system as well, really. And you could probably spawn them all out of the same sort of space. But then you do get kind of overdraw, maybe. It'd be cool though. It'd be quite powerful. Yeah, maybe you can just call this a plant system. um, but yeah, I think that's probably interesting. So a material thickness, a yeah, probably a single material. Or actually, yeah. So each blade can have a, what do you call it, a head? And that could be placed. So you could put things on the end. Maybe it could just be a plant head, basically. And again, that's just a different material. Yeah. But then, yeah, so I think with these things, you probably have two separate materials, one for the sort of stem. Yeah, okay. So we're changing the language now. Right. Maybe a sort of, you know, plant mesh system. So rather than blades, it will be known as a stem. And obviously each stem has a material, has a thickness, top and bottom. It has, right, let's leave it at that. Then each stem can have a head, which obviously has a material and some kind of, well, that would be a three-dimensional dims at that point, wouldn't it? It would be a, just a dims. So it's like a box, box, or can have a box rendered at the tip of the stem, which has a material and some dims. That'd be quite powerful. Obviously, it's affected by wind and stuff like this. So the pro is that, this sort of integrates well with the, that sort of volume ray marched, material system we have, right? Or we're trying to flesh out, basically. The cons, though, is we're going to investigate, right? Investigate LOD, maybe? LODing. Got to think about that one. What other benefits has this got? Obviously, it's very powerful in terms of we can like paint down. Like we can basically, this can, we can have brush tools in the editor, right? That's quite powerful. A con might be, not as performant as other solutions, right? You spell these things. English is my first language, please. Yeah, I was spelling it right the first time, then I second guessed it, damn it. Not as performant as as other solutions. But it is very, very very general and configurable, I guess. Right, so it allows for that sort of playful editing and things like this. I want to put some of these plants in here and that sort of thing. Yeah. So what other cons are there to this system? So to have a lower LOD, I think for low LOD, so lower LOD, so like midfield LOD will just use less segments. Rather we can get away with based on view distance. So that helps. What else? Hello Navid. Welcome sir. How are you doing? But then sort of far field LOD. I don't think we should really worry about this yet. I think this should just be a future problem. This is like future Henry to solve this. Because I don't know if we're really going to have those sort of camera angles, right? So maybe we should not try and solve this problem now. But if we are, maybe we can spend like a few brain minutes to figure this one out. But what could be a thing that we might do? Obviously, a solution would be you swap in some kind of other mesh that comes in that just generally covers the area. And I think that's what you might just have to do. Yeah, I think there is those sorts of solutions around, so I shouldn't really be fussed about it. You know, future Henry problem. I think that's a good way of saying it. So they're going to be pre-placed down by the editor. I guess you can also support like clumping as well. You could say, you can support brush things and like how you clump some of these blades together and stems and things. And yeah, I think this is probably a good solution. It sounds pretty fun actually. And it doesn't actually require a separate mesh system either, really. It could be different from the other mesh system, more specialized one, just a plant system. Now, I guess how would like, and this would probably be separate from a tree. So the another thing we might want to cover, this doesn't support, is so you might have a mesh. Okay, say if you got one of the hang on a minute. Plants. I'm even looking at plants. But yeah, so sometimes with plants, okay, you got these very viney plants. It can't really do those. That's one downside to it. You've got these things you can probably do because it's a stem and then it's just a wide, fat thing that goes on there. So it probably also needs an offset as well. Let's put that on there. An offset on the tip box, whatever that is. So you can support stuff like this. You could. Some plants are like this one, but I guess for that you just don't have a tip. So you just have a box which goes around. And I guess what you could do is, as you're doing the the thickness, this would be like a 3D thickness, because hang on. Yes, I think this is kind of in the vein of material. So, say if you make a particular plant. Yeah, I think you're gonna have to make like a particular plant type, and that says, "Hey, I want this material for the stem and this material for the tip." But then also, there's going to be sort of constraints going on. But each stem instance might have randomized thickness or something like this. So I think we might have to classify a new sort of plant type. Would basically define a it might classify a stem material, a tip material. It's going to specify sort of the thickness of the stem. Yeah, and also one of them yeah, so some plants obviously become sort of tree-like with branches and stuff, right? So maybe do 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 do. Yeah, maybe it just all falls into the same sort of system. But yeah. So there's sort of like yeah, it's like a small stem, a big tip. This one we could just put a big old box around it, and then this is all dealt with in the shader code. It's just a different material. So it's just a bunch of repeated leaves around a an SDF that you rain march against, possibly. Have to figure that one out. It's like aloe vera, isn't it, or whatever it's called. It could just be a stem. Okay, so what else are we missing? So the plant type, I was trying to think about the thickness of things. Yeah, so there will be probably known as a scale of like yeah, because if you move the camera back for some of these, they'd obviously be so small they'll disappear. Yeah, it's very art driven with whatever the game you'll be making. Do 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 do. Okay, so I was thinking then the thickness of the grass or whatever it is you're doing, does the plant type define like the bottom and top thickness, and then you just have a scale of the yeah, you probably want like a min thickness top bottom, a min max thickness top and bottom, which is going to be 3D. Then it also describes a length as well with that. Okay. Yeah, so when we're talking about so the tip offset and the tip dims min and max, if you will, tip min max dims. So you could probably yeah, so maybe you can have like a size parameter, if you will, and that just basically goes more towards the max side of things, and that might be good enough, and you randomize between there. It may be what you instead just have is a scale or an age, you know, uses the plant's min max. Right, so this would be the plant and you probably have like a plant instance, if you will. The plant instance will just obviously have the type of plant, so you can access all these properties and things. Then you will also just have a size. Like, what is the sort of... I don't usually like using the word size, because size in my code bases always means bytes. So maybe we can use the word, just call it, maybe length is fine, because if you just call it length, like the longer it is, typically the wider it is. Yeah, so maybe we'll have a thing called a length. So as the length goes up, obviously a length of... There's a few different parameters, but like you have the minimax length in the thickness. in the min-max thickness thing. So what you're basically saying is as you go up as the thing gets bigger, what is as the thing gets longer, how much variation can you have in the thickness? So maybe you just call it thickness variation. So this will basically allow long length stems to be smaller. Something like that. We've got to figure out how. There should be a better name for that we can put in. Okay, so this refactor's made sense. Now the question is, there's still one more problem to solve with this, and that is like plants which kind of look like trees. So we've made the grass be able to support kind of flowers, which is nice, or even bushes with this thing. But then if you were to say support more of a plant-like thing, like you can even support these guys as well, I think. Or maybe you can saw that as like a tree with lots of little plants off it, maybe. But yeah, this one could probably, since it's so small, could just be one mesh, and then it's all done in the shader code, and that way you can do the LOD stuff all in there, kind of thing. Kind of. But when if you were to ever get up close, you could show them more individually. But it's just a case of ones like yeah, so this one here, if you can make that out on stream. This one here, right? It's kind of got a stem, but then it's got other stems. Bum, bum, bum. So that's kind of forming like a tree. And obviously if you were to form like, do we want to support like stems of things? Trees and stuff? That kind of gets into a bit more of a bigger system though, doesn't it? That could be interesting if it's all just one system. But then if you do that, you can't make optimizations like if it's just one. Well, you probably have to have different rendering paths. Like, hey, this is just a one stem thing, or this is a multi-stem thing. Tree of stems. But yeah, so you could. So I think this is to be the last feature we need to support. Which is kind of cool. So, the stem. Right, we got a ground. So, you sometimes have trees, right, where it's just a stem. So that would just be a box that is of a certain material. Hey, this is maybe this could be a tree material, and we specifically model that tree. Maybe that's just the trunk, right? And hey, there's a branch, and this again would just be one of those branch materials, and it'd just be there. The issue with doing that though is what would be the issue? How would it look when the two meet? I guess you could, like, in real life, you look at it, you see one coming out of the other one. It just depends on the thickness of things, really. maybe it might just look okay. But yeah, then obviously on top of here, you finally have your stem, and then it's got your, you know, the tip. And so this is just a plant, right? This is literally part of that grass system in a way, or that plant system. And obviously the plant system, if we're going to use it for grass, it's got to support, it's got to support laying it out and brushing it down on the ground. So there will be different systems. But yeah, this will be all. So I guess this would be known as like a. Wait, it's like a hierarchy of things. And this thing as well could possibly have a tip on the end. I don't know. The trees really have that? I don't think they do. Just go to an end. But you know, some trees do really have a tip on the end. I think you've what you got? You got the do. So you just get the trees in England. Oh yeah, oak trees and stuff, nice and big. But yeah, so. Yeah, modeling each and every one of these things will kind of be a bit much, but you could do it. Yeah, maybe we can leave trees for later, but it's just interesting to think, could this system be expanded for trees? Maybe, right? Quite possibly. It could be expanded for trees. But that would be... Yeah, so... There are some of those other trees, though. There's like a... of a tropical tree, I think you'll call it. Yes, they typically have a long stem. Yeah. So that's like a palm tree, whatever it's called. But there's some other ones as well. Okay. So yeah, I think we'll have to, you know, can later be expanded to support trees. I don't think it'll be too bad to do that. But yeah, I think that's a cool thing to do. Would you call is a tree known as a plant? Is that technically true? Cool. So a plant system is a good name. So for now we'll just support a one stem, but we could support multi-stem. So you call that multi-stem. Yeah, I'm quite sold on this idea because I think it offers that sort of flexibility and that sort of ergonomic thing I was talking about, where we want this engine to be kind of opinionated, ergonomic, for someone just to use and do stuff. You know, you can paint down different areas and that. Yeah, this does require, though, figuring out like a height of the environment and stuff like that. Probably. And then if you move the environment, you've somehow got to move the grass blades with it. But that's stuff to figure out for the editor, I think. Okay. So we could also support 2D boxes as well if we wanted to. No, we'll just do the 3D one. Nice. So what other problems are there on this? Let's see if we can find any more issues. So the pros are it integrates well with the current volume remarch material system that we have. We can support brush tools in the editor. Very general and configurable. Right, that's the way I'll typically try and lean towards over performance if we can. I'll try to make the most super performant thing, but at least the most easy thing to build. But obviously we want to try and do performance as well as we can, right? So not as performant as other solutions. Right. But we could do a 2D system in the future if we wanted, right? And we can add a 2D spline version if need be. So it's always correctable there. Lodding, we've figured out, I think, just use less segments or, you know, probably a, you know what, leave that alone. Yeah. Could be a custom if we need. Okay, cool. What other cons are there? So the other con is, so right, imagine you've made a level absolutely filled with grass. Yeah, I'm not sure how this will work with like ray tracing and that in the future. Depending on what we do the GI, maybe you have some problems. Maybe so off the screen you don't want to render any grass, but then obviously if you're doing GI, you're gonna need to render them in some way. So they will need to be animated off screen as well. But yeah, the GPU is usually pretty quick. Anyway. Well, I think let's just roll this system for now. I guess the pro could be you can get some nice procedural animations. Right, you can get sort of like, obviously, you know, wind, player interaction. You can also get some nice. Oh, I completely forgot about this. Yeah, this is very good. Very good pro. You can also get some like growing animations as well, possibly. Right, if you wanted that. Yeah, that's true. Right, I'm sold. So I think let's, for now, let's get in. What do we do? Do 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 do. Yeah, so maybe we can use. Like we just need a floor down, right? So maybe we just put a floor. I was just thinking just then about, maybe we should do like an earth material, some ground, some dirt. but we'll do that after the grass. We'll just put down some kind of plane on the floor. Yeah. We can even just do a debug plane if we really care about it. So, right, so okay, so let's just comment all these mesh instances out, I think. What I want to do, does this still run? Do we just render sky? We do just render sky. So the next thing to do is just put out a debug shape. So that goes somewhere. I just got to find where that somewhere is. So frame. Oh, this is initialization. So I think they've got to be put in before we upload the storage. Perfect. So we just want to put a plane down. Here's the plane. So that's the normal, and the color shall be, let's do a gray. Sorry, it's called RGB 8 now because I've got an RGB 1010-2 because we support HDR and stuff. So, you know, these are debug things. So we render those in Rec 709, but we transform it into DCI-P3, which is what we render in. So the colors might look a little bit off for you guys on stream, and sometimes the brightness because I'm in HDR mode. But yeah, I'm in stream in HDR. So we probably just want to do a gray. Gray 6 is kind of like, do a gray 4, it's like a quarter. See what that looks like. Let's try that out. And we see nothing. Why is that? Is it because it's too high? Do, 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 do. Do, 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 do. We can get RenderDoc open. Is that going to be helpful? Oh, this looks kind of weird. Yeah, the color's a bit off. Oh, it's doing this undefined image thing. That's kind of cool. Telling us we've got a problem. Yeah. So somewhere in the pipeline we're not clearing it. Ah. Right. Oh, there's an alpha, is it? Do 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 do. So I think that would be in graph. Hang on a minute. Scene shade. So this puts it into the. Are we saying? So we've got an alpha, isn't it? So post process, we don't really care about alpha at this point because we've done all the alpha. So after post processing, we probably want to say we don't care about the alpha anymore, I think. Just put it at 1. I think that might be the issue that's going on. So let's see if RenderDoc likes that. Right, apparently that was not the issue. Let's investigate that a little bit further. It shouldn't be too much of a detour. So, draw 2D, draw 3D, bloom passes. Scene shaded image, exactly. Hang on. And then it gets right, so the UI also has an undefined thing. Do we image UI? But then undefined is fine for the UI. What about the post process? What are you doing? Seems suspicious to me. Oh, so the undefined image is getting downsampled and then bloomed and all that. So, yeah, I think so from scene shade. We want to sort that out. So I was right the first time. End of scene shade, we'll just down that to 1. Still looks a bit weird. This undefined sky. Does that mean it's not been written to? Pretty sure that's what it means. Yeah. So yeah, yeah. So they're not been written to yet. You've not done a load, so it's kind of could be in any state. So RenderDoc fills it with this, so you can catch these problems. But oh, is it trying to blend it on top? Sky. Right, is it coming from the sky? You clear the whole bloom. What that copy's doing there. Kind of forgot what that does. 2D, 3D. Right, so there's the scene shaded image. That's kind of nice. Yeah, it looks alright. So, what's this guy doing? Oh, the scene shaded image was told it's undefined. That's a bug. So, it's nothing to do with that, I think. It's to do with when we do render the debug shapes, I think, draw 3D, which are the things we're trying to use. There's a... No, we said the load. Don't lie to me. Load store, load store. Anyway, let's take a look at this. Actually, there's one more thing to check. What are the pipeline barrier? So the pipeline barrier says, yeah, old layout general. Color attachment, please. Yeah. Then, depth is undefined. Yeah, that's true. Hang on a minute. That might be a problem for... Yeah, there's a slight problem. So maybe it's infecting the scene shaded image. Because of that reason. Right, so what we did is we added this thing called... We added this... for a 4-layer render buffer for the object ID and the depth. So now I've got 4 layers of depth buffer per pixel. We have order independent transparency, and I haven't really got that bit working yet, but we did it because of we're very much in volume, so we can see what's behind the volume. Now, and also for transparency in the future, which should be quite easy to add now. So because this depth is not being used anymore, we should, and it's only really used, right, we should populate the depth from the scene after the scene pass, the scene shade. We should populate the depth. Let's do this properly. So scene shade, and then we want to write another one. I think you can do this as an image. GPU VK image copy or copy image. I forget the order of these things. Copy. Yeah, this is gonna be cool. So we want a destination image, scene depth. We also want we don't really care about offset. We just want probably the nearest. Yeah, it's gonna be that same size. So let's do that. So scene depth layer image. So it's got 4 layers in it. So it's just 4 different channels. Yeah. I wonder how that'll work. Let's just see. Let's see if the thing doesn't want to work. But image, copy image, copy, and voila. Yeah, I think that's fine. So let's investigate that. Does it work? Right. So scene image. Yeah, right. It needs a transfer destination. Hey, Chino. Sorry. Sino Vino. Boy, no. That is a tongue twister, my friend. But hello, how are you? Yes, I'm good. I'm not bad. Yeah, I was super tired this morning. I stayed up a bit late last night, but as the day's gone on, much better. Yeah. So I've had a good day so far. How about you? We've just been planning out the grass, and I ended up basically generalizing it as I sometimes do with these things. But we've designed this now a plant system, so it's more than just grass, and we're just sort of getting the footwork in for that. If that's how you would say it. Yeah, just getting the basics in. So I'm trying to draw like a plane. I've just got a little bit sidetracked to trying to fix something small in my renderer. To do with, because RenderDoc is like, this is wrong. So I'm like, okay, fix it. Yeah, we need a transfer destination on this guy. I'm sorry for the hard pronunciation. I'm good, thank you. I would like to ask you something if I can. Yeah, of course you can. Yeah, it's fine. You have to apologize for your name. I think quite a lot of people's names always end up being hard to pronounce because it's just a quick thing you just write. Don't really think much about it. But it's fine. I can just call you Sino. Yeah, Sino. That's your nickname now. Unless you've got another name you'd like me to refer to you as. Okay, so this one, they need the transfer source. Of course you do. Come on. Thank you very much. So where's the layer image? And right, more problems. Oh, we need a maintenance 8 feature. Can you not copy depth without maintenance 8? Yeah, this is Vulkan for you. So color does not match depth. Ah, so one of them is a depth texture. The other one is just, you know, a vec4 of float 32, and we manually encode the depth in the mesh. I call it a layer buffer. You know, it just uses that pixel interlocked unordered, and we just lock the pixel per pixel mutex. Let's go. We load in the 4 pixels, go over and basically put them in sorted, and then store them all back out. Yeah, good times. So it doesn't use the natural depth buffer, but this one is a depth buffer. So make it a 32, please. So we then need to go deep into the Vulkan stuff, find where it says features 1, 2, or whatever it is. Yeah, good. What's maintenance 8? What is that thing? Yeah, this maintenance stuff is just weird. It's like, oh yeah, we just got a load of little things where we want to make an extension. So here you go, maintenance. I'm failing at English, which is my first language. Please bear with me, it's my first language. Maintenance 8. Oh, it's a whole separate thing. Lovely. Let's just put that in there. Hey, Psychode. How's it going? Nah, you're not getting my Lord. The only person who gets Lord, Jesus. And God the Father. I guess the Holy Spirit as well. I generally refer to them as Lord. Exactly. Yeah. Name is Aran. Nice. Nice to meet you. My name is Henry. I'm approaching 2C. Do you have any tips for me? I would like to start well, but with all tutorials and books online, I don't know where to start. Yeah, so C is great because you can basically do anything in it, and it's very powerful. It's awesome. And these days, you actually have a lot of access to the things, resources and things. Um, you know, if you want to try and make it a bit of fun, although it might be a bit of weirdness trying to get this thing set up, but especially when you're trying to come into C. But Raylib, when you've got it set up, because it's not that Raylib's the problem, or maybe it could do its library stuff a bit better, but you have to like link a library, and linking a library is like, it's a whole thing in C. But the reason why I tell you to install something like Raylib or something is you get to have some fun and use it to do some 2D graphics and stuff and just get stuff up and going. And when you're coming and learning C, it's a great thing to, you know, they give you the code to sort of copy paste in and, very simple and you can get stuff going and learn C this way, rather than just sticking to a command line application. So it kind of makes it more fun. So I think start with trying to make stuff fun, and then you also want to pick something that's super super small to make. There is lots of other projects as well. Um, yeah, Railib is quite good. Yeah, for people who just want to, when you want to like put something together as a quick demo, I've used it to do some image processing before because I was like, let's just get this thing and quickly do some things with it. But yeah, so it's very easy for beginners. He also has a, Ray, that's why it's called Raylib. He has a Discord and a community on there, whereas tons of people have probably gone through the same sorts of stuff as you. But yeah, you just want to find a small project, right? Maybe you recreate Tetris, right? Those old classical games, like maybe Minesweeper, right? It's a bit boring, but or maybe you find it fun. But one of those old classical games. Find the one which you find the most fun, but is also stupidly simple, and then yeah, just keep going from there. Really, what's your aim with learning C? By the way, is it? I guess that's the other question. So this is more of a sort of like if you want to get into sort of games sort of direction, but it can also help you learn C in general. What else? You know, another one. Uh, if you want to learn about how assembly works, you can write yourself a. This might be a little bit more next level, but you can write a NES emulator. I think this is not too difficult. So they basically provide CPU instructions. So it's 6502, isn't it? So it's an old CPU. So you can learn a little bit about assembly and how that works by literally writing an emulator for it. And there's a ROM you can download where it basically tests all of the instructions out. There's a test ROM, and you basically can load this test ROM in, and it just goes through all of the instructions and tests them out. And then if your emulator doesn't crash and it performs correctly, then yeah, there's different tests and stuff. So there's all lots of. I think this website is the place where you get all of the information from. But people have done this and built an old Nintendo emulator, and yeah, this could be one of the things that you build to help learn about assembly, because ultimately when you want to learn assembly, it's easier if you learn the older hardware because it's more simple. I think the 6502 instruction set basically fits. There's a byte for the opcode, and then there's some extra bits in there and that. And it's very simple. There's only like a few instructions, right? And you can learn about how CPUs work at the same time, or understanding a more simple thing. And this will help you map it to something more modern because you have some kind of idea now how things work. Why does everyone want to make an emulator instead of a game? It's not too hard. NROM without mappers. What do you mean by NROM without mappers? Well, I'm saying it as a learning exercise, right? Because the idea of, like, if he wants to learn about assembly and how to optimize, right, and learn C, coming down from the layer of C into assembly can be quite daunting. So if you can make it into a fun task of, and learning where history was and where we came to now, that's the idea about the emulator. In September, you start uni computer science, but never programmed before for a little bit in Python. I'd like to learn something before. Nice. Cool. Well, that's great. You want to learn stuff before. I don't know how much universities teach. Well, it depends, right? Yeah, I don't know how much they teach programming these days. I know some don't really teach it very much, so people come out just getting their feet wet. So if it's something you really want to endeavor in and do, get into as a hobby, definitely pick it up now, before, because I wouldn't rely on school teaching you well and also teaching you in depth. And yeah, by the way, there is a Discord. If you're into Discord as well, obviously there's the Raylib one. So you can come and chat with the people on our Discord as well. In the meantime, NROM is the or interesting to see you doing grass here. I probably watch those Sucker Punch talks 3 or 4 times. Nice. Yeah, I'm doing something that's kind of inspired by the. Yeah, it would be that. Yeah, it's this one, isn't it? It's this Sucker Punch. Yeah, yeah. Yeah, it's inspired by this, but it's not the same thing. It's a bit different. Fits in with the way that we're. It's probably more of a more complicated version. We just written out this plan. You can screenshot it, maybe. Get your screenshot ready. Hang on a minute. I wrote glass instead of grass. So method 2 we're thinking about, so it's inspired by their one, but it's going to be a 3D box around rather than and it's going to be a plant system, because I was thinking we could probably just make it support plants as well, type of thing. And later on it could expand it into trees if it have multiple stems, basically. But yeah, we'll be working on this over the next week, maybe. It'll be cool. It'll be cool. Physical device, maintenance, 8 features. If this becomes a problem with hardware support, we'll just roll our own compute shader, maybe, or no, I don't think you can do it via compute shader. You do a full screen pass pixel shader, anyway, and it will do it. Cool. Does that run the thing? The earliest, easiest way to write a NES game, like Super Mario Bros. 1 in the early days, before they added extra ICs to swap out sprite and banks and stuff. Like if you want to write a NES emulator, you only want to support NROM. It's much easier than implementing the behavior for all different mapper chips that came later. Right. Fair play. Yeah, I guess write that advice down. I'm not sure what this NROM thing is, but oh, it's a specific cartridge board. Right. Yeah, yeah. Probably do something like that. Just support the basics. Don't support like all the crazy stuff, obviously. Don't go and try and get the what do you call it? The Star Fox 64 going. No worries, sir. Can you share the link to that presentation? Yes, I can. Oh, sorry, you write something earlier, didn't you? How's it going? Yes, it's going very well, thank you. Hey, it's me from the past. Infinite Henrys. There we go. Do 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 do. Yeah, I'm doing good. I've had a good day today. Went out and saw some people, which was cool. I got like a little bit of time to work on the business stuff this morning, so I made some progress there. So it's been good. Family's good. Work's not bad also. So yeah, doing well. It's only to allow. But yeah, how's things for you, Psychode? This is only to allow for certain sets of formats during copying with maintenance 8. It says not size compatible, right? So we might as well just get rid of that feature and just do the thing. So, right. Now we've got to deal with the fact. Now this is why GPU programming sucks. But we have to do it. Like, it's got areas which suck, but it's got so many areas where it's like, this is amazing. But anyway. So we can't just use copy image, and we can't just use a compute shader because the destination type is a D32. So what we have to do is do a full screen pixel shader, vertex shader combo. So here we go. I'm so getting detoured right now, but let's do it. Let's explore the fun. So basically, we're going to make a new shader and we're going to call it. I should really bookmark this. Oh, it's already kind of there anyway. There we go. So we need to make a new shader and we're just going to call it a full screen VS basically. Full screen VS. And all you need to do, it's very simple, is hang on a minute. Take the vertex index, you'll have 3 vertices. It's just a triangle. You -1 to 1, but you need to make it go away to 2, I think. I can work this out myself, but maybe we'll see there's a quicker way to do it. See that AI can just do it for me. But the basic idea is if I Milton draw it to you guys, you understand it. You got a screen, right? You just need to lay the triangle here and then going off the screen by double the amount. And then when you get, oh, it needs to be double the amount both ways, I think. So then when you get the diagonal, it sort of just goes there. And it's better than doing a quad because the problem with a quad, which is 2 triangles, is you basically get all of the pixels within here when they're being rasterized. It's done via 2x2 quads, and the 2x2 quad might you'll have some inactive lanes in the quad because they won't line up properly, and yeah, you'll not get good occupancy. So the best thing to do is just do a full screen triangle. So yeah, you want a 3. Yeah, -1 and then 3. So it's 1 would be on the right. And okay, 2 over. Right, okay. So no impact is needed. Whoa. Revolutionary. Hey, Perry Perry. Oh. How's it going, sir? Now let's do a thing. Yeah, that's a bit weird. But anyway, cool. Law of Lair. Law of Lair. I think that's fine. But yeah, then you just want basically a... So you do a full screen. Yeah, I'll get there. The other one was like a color. So copy depth. So copy layer depth to a depth buffer for the debug rendering. So dot pixel shader. So to copy the layer depth. Oh, go back there in a minute. So we want to know GPVK no push constants. Now the layer depth, you're taking that from a... Oh. You know, we use the no push constant, but no push constant has a placeholder one, doesn't it? Yes, we'll store in placeholder the U32 and cast it around, and maybe. Because that way it can be used across... That full screen can be used in multiple ways. Yeah, maybe we can just call that general later on and just have a bunch of U32s you can just manually poke in the... and reinterprets whatever you want, but anyways. So you need to get your pixel, which is like GL fragcord .xy. Then you need to floor, because there'll be a 0.5. And then you need to convert that to an IVEC2. Yes. And then that would be what's known as a coordinate. Then what you can do is you want to set the depth, G depth. Man, we're going to have to do a whole pipeline for this as well. Ah. So there's an image load. I just got to find that image. Man, this is such a crazy detour. It's nuts. So placeholder. We'll cast that into a RGBA 32F read only load. Award dot X would be your depth. There we go. So that will be the shader. Now we just need to do the whole crazy thing of changing the build system, adding these lines in. So there'll be a vertex shader. Sorry, this isn't the crazy thing. I was just working myself up for... So the full screen pass, and then the copy layered depth thing, copy layered depth. The thing I was working myself up for is we're now going to make a pipeline. We've now got to initialize it with the pipeline state, and then finally dispatch it. Yeah, Vulkan. So where's the pipelines to find that? Right, G pipelines. So we'll call this one copy layer depth. Or just to copy depth from something which is a color buffer to a depth buffer. Right, let's find something simple. That 2D one will probably be it. Let's take this one. It's not really part of the mesh system. Oh, we can all put it together, I think. What function is this in? Nothing. Right, group. Lovely. So we just... Cool. Having a good time myself. Didn't sleep much, but pretty great otherwise. Nice. Yeah, same for me actually. I didn't sleep too well last night, but thankfully the day's progressed and I've filled my system with food and other things. Like a sweet, sweet Pepsi Max. All finished now. Feeling better. Peri Peri, fine, thanks. Working on my 2D game. Nice, at least trying. Cool, cool. Currently playing around with a level editor. Very cool. Yeah, having a level editor in the game is good. Very good. Obviously, if you can get away with like doing it from external files, that typically is easier, but to implement. But you can, but it can lead to things being quite um not very what can I say? It can lead to things if it's done externally to be quite a pain sometimes to edit. It just depends on your system. But also it can lead to, yeah. But the pro is that you can develop it a lot quicker using external tools. But if you build it in the engine as well, you can integrate it super nicely and make it very ergonomic to edit. But yeah, the progress on the engine is going all right. We made this last stream. Where are you gone? Hang on a minute. This one. So I've got some moss. You know, you can kind of tell what it is when you look a bit closely. It's not really, it kind of looks like moss, right? It's moss-esque. That's the word I'm trying to say. Not mosque as the moss-esque. So effectively, it's just 3 spheres randomly offset inside a volume, and then noise is applied on top of that SDF that we remarch. And it's okay. There's a seed as well, so you can change it and you know, get different shapes and stuff of moss, and it's okay. It looks all right. It's also colored as well. It's like a bit brown. It kind of does the job for now. We could probably do a much better job later, but for now this is fine. So we're just trying to do some more. I'm trying to explore this material space, like, you know, how do materials work in the engine, and in what ways do we make meshes and materials, and what things do we offer. So I'm sort of just exploring the space, and I think we're going to spend quite a bit of time just making different materials and making the system work for that, and then we'll build a proper mesh system on after that. I think the main focus is just find the shape of things basically as we add different features and things. It's cool. I like it. I like that. Yeah. Excited to see how the grass turns out, or it's a plant system now. I should really change the stream name next time to a plant system. Copy layered depth. So full screen. What sort of a 2D game you're making? Have you got like a genre or something, or a game it's going to be like? So I could understand it. It's a triangle strip. You can just do that in, well, no, you don't need. You still need a third. Just do a list. So primitive restart false, depth clamp false, culling mode false, depth test false for depth, right, true. Right, because we're writing from the pixel shader into the depth buffer. Compare never. Right, so that should hopefully be quicker. Blend states. No color. Attachment. Right, so now we've done this faffing around. Hang on a minute. There we go. So we just want to simply so bad. So finally in scene shade, we'll do that shader, render shading, here we go. So rather than just doing a simple copy, which we hoped to do, we now do one of these. But it should be able to be minimized. So attachments would be nothing, just a depth attachment. Scene depth. This can be the load up of nothing, whatever it's called. It's called don't care. So it should never have to load from memory. We just store. It's called copy layered depth. No color attachments. I'm not sure if I've done this yet, but this is the depth. You know, the scene sort of stuff there. The push constants that we're passing is a no BC. So in the placeholder, we're just going to store the. So where's the sync, that code up there? So sync image 2D, RGBA 32F. Yes. That's storing 4 layers of depth, and that is in the scene layered. Hang on, don't do this to me. This is read only. That's the one. Scene depth layer image. Then we just do a dot and get the rest of the thing here, which is not showing up for some reason. We did it in the post-processing, I think. Right, so that will be a... What's the naming convention for that? So the reason why we do all this is so it becomes type safe. So when we have type safe image IDs and it's just an index, that's all it is, a wrap structure. But the member where the integer is, like the member field, the field, right? The name of it is a distinct name per type. And the reason why we do this again is for type safety. When we use there's a macro, like an image or like a fetch, yeah, these ones, these buffer read-onlys, image read-onlys, it requires that how it does it the type safety is it, you know, procedurally generates the field name for that thing, and if it's wrong, you've obviously got the wrong handle. So yeah, that's how we do it. So yeah, we have things like this. Maybe I can make more macros to make this thing easier, but there we go. So it'd be RGBA 32F. Cool. So that's fine. Do some drawing. Use the copyleft depth pipeline. There's no indirect arguments. So that would be draw with a vertices count of 3 and a vertices start index of 0, if you will. Let's just be a bit explicit with that one. Instances, I guess. Instances of 1, instances of 0, and voila. Then we just do a draw. And then you do end drawing. Right, that was kind of crazy, but there we go. Not sure about the genre. I just want a level editor and some tooling so I can quickly prototype ideas. Nice. Good. Thematically. Didn't realize that was a word. I want to be centered around clowns. Bum bum bum. However, I don't know if I'll stick with it. We'll see after the prototyping phase. Cool. So I'll be featured in your game. Hmm. Um, did I call it the wrong name? I did PS for pixel shader, damn it. My mind has been infected. Hang on. Why was there a few copies of that? I'll check my... Okay, so full screen is a problem. ID is now index these days. GLSL to the rescue. So, yeah, anyway. So the fragment shader has a problem. Oh, yeah, so we have to wrap this in a specific ID thing because type safety. So yeah, we're doing it in a non-type safe way and then wrapping it, pretending it was type safe all along. It's amazing. We do it somewhere. I've done it before, right? It's not the only piece of code where I've done it. It's in the texture image viewer copy, surely. Yes, you do one of them. Right, so Yeah, so you do this, RGBA 32F, there'll be an image, then you just do the constructor thing around it. Alright, what are you complaining about now? So that'll be too few arguments for image ID. Really? Oh, it is, yes, that'll be read only. Cool. GL depth. Um, oh, frag depth, of course. Frag out. So we did change the depth of this thing. So must match the corresponding one in depth attachment format. So that is in render shading draw. Yes, the thing we just wrote. Why do you get an undefined? Did we... That's weird. Right, so you have a depth attachment. So is there a format somewhere? No. So over all the color attachments, if depth attachment, right, just puts the image view in there. And then... Oh, of course. Pipeline. Yeah, so the pipeline we've just made. Yeah, so that would be... Oh. D32 as float. Yeah, we'll change these because I changed it to D32. Hang on. Mesh render. No. Okay, that was ignored. Okay, so I think we're up and running again. That was quite the detour to fix a problem that RenderDoc told us about. But it looks like it's still kind of there. What's going on now? So where's the copy at? So scene shade. Oh, there's 0 there. Doesn't look good. It's fine. That's fine. Right, there's a depth only pass. That's the histogram gather, so this would be the scene shade. Yeah, the full screen pass. So here the depth images load don't care. Did we not write a pixel out? Oh, for crying out loud. This one. So I think you have to have depth testing enabled to have depth, right? I think that's what the problem is. Like, if we look at the pipeline, yeah, it's the whole black box system, but here we go. Graphics programming. Where is it? There's the, is it the mesh viewer? Oh no, there's a pipeline, one of these, I know that. Yeah. Wonder where that went. But yeah, so rasterizer. Frame buffer depth. Right is disabled, you see? Depth state, because depth is not enabled. So hang on. Yeah, I put it to true though, right? And this is the, let's double check. The vertex shader is, hang on. Yeah, full screen mixed with copy layer depth. Cool. Yeah. So what I need is an assert in the code base for that, because you know that's an error prone thing and we won't catch that unless digging into render doc, which is time consuming, that's for sure. Let's just double check that's worked, and then we'll put the assert into depth only pass here. Pipeline state. Yeah, depth, right, cool. So at the end, texture viewer. Come on, work with me. Scene will be infinity. The value is infinity, right? So it should be right infinity out into here. $54. Yeah, depth is infinity. Yeah. All I want to do is copy a buffer. Yeah, here's the full screen triangle. Yeah, it's around the screen basically, which is cool. So that's obviously working fine. It's just the, yeah, we do say to the depth. There's no resolve, obviously. Depth. Store is store. Load don't care. So Why you no store? That's the question. But yeah, let's put that debug thing in. Sorry, the assert. So the assert would be that pipeline spec depth test. So either depth test is not enabled, and then it's fine, or depth right is not enabled, and that is when it's, hang on a minute. Yeah, I've got to rethink, I've got to think that logic. So basically, depth test needs to be enabled if you have depth right enabled. So I think we can just write that a bit easier where we say, we just invert the logic. So if that is enabled, yeah, I feel like that's wrong. So if depth right is true, we want to ensure depth test is true. The depth test can be true and this one can be false. So would that just be depth right? Yeah, I think this is right. Okay, so we had depth test enabled, then yeah, this wouldn't work, will it? Right, it's right again. It's right from the opposite way around. So if this is enabled, then let's just write this way, it'd be easier. So if depth right is enabled, then depth test, if not, it's just going to pass. Then assert this is true. Something like that. I think that's it. So if we just test it out, if you put this as false, that's going to assert, right? Yeah. All right, cool. Nice. So if we put that as, yeah, I think some of them have depth right as false though, right? No, they don't. So let's test that example quickly. So we make this false. So the problem is there's never, okay, so that was fine. There's never a compare up. So I think we want to say always. I think that's the problem. Always. Always pass. I think that was the issue with the copy. man. Mhm, mhm, mhm. Oh, perfect. It's doing the copy. Yes. That didn't take time. All right, so I think we've yeah, so now finally you see there's no undefined image in here. Oh yeah. So now we get to do yeah, I think it's running the it's running the HDR one, but for some reason it's not making it look very nice. Oh well. Right, I'm just gonna refill my drink, I'll be back, and then we'll check to see why the plane isn't being rendered. And we'll look at that. Right, BRB. Lovely. Welcome back. So, why do we open RenderDoc in the first place? Well, it wasn't to fix that problem, that's for sure, but I just couldn't help myself, and then it led into, like, you know, making a whole new pipeline. But anyways, it's done now. It's good. I didn't see that undefined image plastered all over my render now, so things are now more correct. And to be honest, it's fixed the debug drawing. So in the debug drawing, we have a flag, and this flag was broken, and now it's fixed. So since we added rendering multiple layers, or the layered buffer, so we can do order independent transparency and stuff like that. For the draw 3D debug stuff, so we can debug draw a plane. We have support for a depth test, basically. I don't know why there's no Z test on this one. It's interesting because you want to draw the objects on the plane. And that will just cover everything. Yeah, so we need to probably add Z-test to that. Let's have a look at that. We're trying to draw a plane basically. So why don't we see plane? So I think it's trying to draw a. We're trying to draw a plane, so we put the grass or aka plants on there. So 2D's not got anything. So UI. Where's my 3D? Oh, I think I disabled my 3D rendering. I think that's why. Right, it's before Bloom. So Bloom's the compute pass here. We should probably have some labels for these really. But anyway. Yeah, we got those profile markers, haven't we? So that should be going up in here, maybe not. Yeah, I wonder what it would take to get that in there, because we have profile markers down. Yeah, well, we can add support for those. Should be able to do it. But yeah, so 3D, here we go. So mesh, here it is. Ooh, so it's actually like, oh, it's just a super big box, and here's our viewport, right? So is there any pixels? Because the plane is like infinite, right? So in the texture viewer, so the scene that you're trying to draw onto, scene shaded image, we're trying to say draw. So wrong button. History. So what happened is the depth test failed because the depth we're trying to draw has a depth of 0.24. And what we're doing, is it a greater test, is it, or something like that? Oh, it's always, okay, the plane is always Z tested. Okay, so we've not, yeah, so we don't have that flag on it, that's why. So, always depth. I think we should be seeing it because it's 2 down and the normal's going up. Do 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 do. Greater. Yeah. So that is Z. Ooh. Okay. Yeah, so Z test is first. Good. So that is being dispatched properly. It's just the shader logic is busted. So draw 3D. So we write out. Here we go. The Z test. Write the frac depth. All right, raster from linear depth. I want to debug print some of this stuff out. Is mouse. Print is mouse. Nice. So we obviously render out to a plane. Right, if is mouse at. So that'll be frag coordinate. Print me out depth. Right. Yeah, I think we got the depth comparison the wrong way around, maybe. Yeah, it's basically in front of us, like not that far away. It's like 2 or 3 away. So we're still, it's getting rejected. Probably because why is it getting rejected? The pipeline. Yeah, is it the depth up is wrong? Yeah, the mesh is greater as well. I thought I was doing a reverse Z thing at some point in time. Yeah, I thought I was doing reverse Z to be honest, but maybe I'm not. Right, here's the plane. You can see it now. So we tilt the camera. Yeah, it would kind of be nice if we had a distance, not gonna lie. Be able to tilt the camera. Get rid of the fire. Yeah, so see the floor's been covered with the plane. Right, so we just don't see a sky at the bottom anymore. So it's just been covered. So what I think we should do, it is a bit dark. We can change that gray and all that, but I'm thinking we should add something to the plane. We should probably call it size. And that way if we say, if we find the point on the plane has gone outside of that, then we discard that pixel. And then it actually seems, yeah, I think let's add this. Um, right, so if we add another thing called half dims, I think is a good one. We just do one in every direction for now, just so we see it. Always change it. But let's just trace this all around and put more things. Let's support from the shader side first. So draw 3D fragment shader, so plane. Right, so it just reads in a bunch of words from a words buffer. That's all it's doing. Nothing too special. So half dims. Then it's another one of these vec3. Okay, so we're just going to go 3 plus. Oh. Alright, 8, 9. Cool, so that'll be 10. Lovely. So when we get a hit, we want to get... So it can have different normals, right? So essentially you might want to reproject it onto the plane, and then so find the hit position on the plane. Then if you just did a length op, you would get the distance, but you kind of want it to be yeah, so you must reproject it along the plane. Hey there, Leon. How's it going? Welcome, sir. Why does that time become a water? Yeah, I wonder how you do that. So if we get the hit, we've already got it, right? Hit.x. Hit pause equal ray origin world space plus ray direction world space times hit t. Yeah. So you've got the center position. You can draw a vector to that line. You probably want to compute. So since it's a plane, oh yeah, this is easy. Do you know? Is it easy? So when you have your normal, you kind of know where the yes, as you move I'm trying to think of the perpendicular one which goes forward, right? So you have one which goes like that. So it's the up vector to the normal. You want to go like wait, no, it will never rotate like that. It'll always be to the side, wouldn't it? Yeah, so that will mean it will never rotate. So it's simply just so you want to rotate it along the x-axis basically, just do a rotate. So you could build one of those matrices and do it that way. I think that might be it. Do you want to produce, you got the normal, you would want a forward and a right vector basically. And I think you could do that with a mol matrix, mol v matrix 3D. You want to rotate a normal. So yeah, so the matrix would do a rotation along the y, the x, sorry. That's the thing, isn't it? Cool. So pi is half, so we want to do pi is half the way around a circle, isn't it? 2 pi is 4. So you want a quarter pi. Sorry, half of pi for a quarter. And you're rotating normal. Nice. So then the right vector would be so after that it would probably be if we rotate by the x, no, it would just be a rotate along the z, I think. A twist. You never do a twist. So it'd be a z. Yeah, so let's try that out. So then we just reproject it along those lines basically. So that would be, so that gives you another matrix, doesn't it? Yeah, it's probably horribly, you could probably simplify this a lot, but it's just debug code, so it doesn't matter. So you just reproject it across this. It's just a classical matrix 3D at that point. So we could, well, what am I trying to do? I'm trying to produce it in local space of the position local space is equal to we want a vector. So it'd be position, yes, pos local space equals so going towards the hit position from position, so the center position of the plane. Then with equals normal times as you remap it between the spaces, do the rotation if you will, so it'd be that times. Then it's just an accumulate, isn't it? Right, so pause local space times normal plus, I think this is right. Feels like it. Forward and right. So now you got position local space. So if if all of the position in local space is less than half dims. ABS. Yeah, absolute of that is less than. Then amazing. So we do that. So I think that's the code we want to write. Let's see how that goes. Right, we've got to poke it through everywhere now. Yes, I think we can do this. Fine. So it's possible. Just got to poke that around everywhere. And so that also needs to be done on GPU, doesn't it? So draw.c, remember this is CPU side. So in the game as well, game.h, I think it needs to do it. Right, and then the final one is GPU shared. Graphics shared. Graphics GPU. Oh, so graphics shader. Oh. Cool. So I think it's everything's sorted out. Just got to do the implementation. So up to 10. So we need 11 words. That is good. So it's GPU side code. And in draw C, there's the CPU side code. So that'd be half dims. Just pack them in the buffer and pass them up. And then the final place would be those ones which call this. We need to pass it in. So there's a few places that do that. Okay. Cool. So the final place would just be this is a bit buggered up for some reason. Eh. Does that not want to work? Here we go. Cool. Man, it worked first time, I think. There's our plane. Can you see it? So we've got a distance of 1 in size. This is cool. So if we move the plane about, we've got to try it tilting though. Let's put it 2 in front. The camera's sort of like looking down diagonally, as you can kind of tell now. Now that there's an object on the scene again. So here's the plane. We've got it capped now, so it's printing out the t distance. Yeah, we could double check. So the distance the ray travels, right? But we could double check quickly. Draw 3D. That. Right, so where's the print? Here it is. So we actually want to test where's the position in local space. Okay, so we're looking at +1. Yeah, so as you can tell, the x-axis says negative 0.9. As soon as it goes above 1, right, it doesn't render. So that's the y. The x is kind of flipped the wrong way, but it doesn't matter. I think it's the way we did the rotation of these things. So that would then mean, so what happens if we change the normal, right? So what happens if I defined a normal? Normal equals normalize. So let's do an up vector and a right vector. Does that work? Yeah, so it's kind of slanted, but I don't know if that's what we want. We can keep it going a little bit more. Let's make it 2 to the right. Right, it seems to be not working right. Doesn't keep square, does it? Got to quickly fix that. No, my maths is failing me. So what does the right mean at this point? Like, where's forward pointing? Where is right pointing? Those sorts of things. So forward and right. Where are you guys pointing? Do we need... No. Do we need to do anything? So forward is the 1, 2, 4. So that would be 0 along the Y. Mostly along the X. If you got one like that, you take the X axis and you're saying rotate, you're going like that, aren't you? Right, but really you want the X to yourself. So I don't... Yeah, I think... You know what? I think that there's a function we already have where we can get two sort of perpendicular vectors, and that's all really we're looking for is... I did a thing in the past, I swear I did. Where I got two random perpendicular vectors and I made a function for it. I remember myself doing it. Oh, I don't know why. I searched the same thing again, but I found it, I think. Perp. Alright, this thing. You take a normalized vector. Oh, and it'll get you a perpendicular vector. And then you can cross it and get the other one. Yeah, so we didn't use it in the end. But I think we can basically do that. So we say... So we're just looking for... I don't know if these are forward or backwards, and we don't really care, I don't think. So we can just call it perpendicular 0 and perpendicular 1. There'll be a cross of perp 0 and normal. So perp 0 and perp 1. I think that's all we're looking for. Let's double check it. Oh, I think it looks way better. So if let's double check it. No, it's changing it a bit. No. Maybe. Maybe not. Can I like can I do a sine of G time? Yeah, it's not really what we want. But we can also we can't debug draw from here because we're in the debug draw shader itself. Fun. So I think we just need to normalize one of these guys. Right, what's perp trying to do? It's saying try the right axis. So it's trying to say take the right, and if you do that, you're obviously going to get one where it's like pointing towards the screen, away from the screen, and then you would do a cross again. Oh, then you need to across again to get um yeah, there's real vector codes here. It's a bit complicated, we can't just copy paste it. Or we could throw it into a function and test it out, but so you got the normal. We're saying, hey, just get a perpendicular one. You would get a how much points away from the camera, and then you take that with the cross of the normal, and that should produce you an x-axis type one. And then you recompute x again. Excuse me. I don't think you need to worry about that much. We're doing this wrong. They're all normalized. Right, what happens if we go a bit further? Is the hip position calculated wrong or something, maybe? Yeah, my plane... Nah, it must be right. Just copied it from IQ, obviously. Position take. So you take the hip position and the position of got an arrow toward it. We're trying to go from one space to another. Yeah, maybe I've got the wrong way around of a matrix. Maybe. So maybe what I need is the inverse or something. That could be the problem. Yeah, there's maybe a simpler way to do this. See if we can get the AI to help me do it for a few minutes. So 3D plane, 3D plane, get XY, get 2D XY in local space. Let's see what it comes up with. Right, so you get your, that's what we've done, right? Done a cross, normalize. Do a cross, get the bitangent, right? Tangent, bitangent. Do the takeaway, that's what we've done. Ah, it's just a dot product. Of course. Right, just a dot product. So that would be, oh. Yes, I think we've done it, but we've just done 3-dimensionally. Yeah. That's the problem. So, man, that was a mess up. So, it's 2D. That, take that. Yeah, so it was just vec2 dot pos local space dot xy equals vec2 dot pos local space dot, you know what? Let's call it vector. Vector and perp 0. Vector perp 1. I'll do it. Right, so we should be able to get rid of that. Now, half dims. We need to just quickly take that out. Yeah, so where we did those plane, all of these guys. So 10 words. Get rid of the Z. That 9. All right, vec2. Lovely. Right, I think we're there now. 10. Final one. Amazing. So let's try that out. Hopefully that works. Draw 3D. What you complaining about exactly? So 5, 2. Oh, we did the wrong one. Cool, look at that. Amazing, we've got a plane. So, yeah, we're verified that it works that way. And we just change it quickly to make it go the other way. So we'll make it go along the Z. Cool, that's really nice. So now we've got our debug plane working better. It now supports clipping, basically. You can make it a disk by just doing a length operation. And then you can make it rounded, but I think a rectangular one would be good enough. So now we've got a plane to stick some grass on. We can make it brown and we can, you know, just stick some grass and some meshes on, basically. Cool, 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 cool. Right, so next stream, guys, we're going to be working on that plan that we put together today. Happy with the plan. It's going to be a plant system. You can take a screenshot if you want to read it, but effectively we're going to have... I decided to generalize it a bit and make it fit in well with the engine and the design. I want to do with 3D materials. So effectively there's going to be like bounding boxes of spline which make stems, and those stems can have a tip on the end, and the stem has a material and the tip has a material as well. And so that's custom procedural material shader code. There'll be thicknesses and offsets to do with the tip and stuff like this. And yeah, the pros are that it integrates well with the current volume remarch material system that we got. It supports doing brush tools in the future when we do the editor, make it nice and ergonomic. And it's general and configurable, right? So we can always add more things. And procedural animations like wind, player interaction, and growing kind of work kind of easy. The con is performance. Will be, it's probably not as performant as other solutions, but we could always add a 2D spline version as well if need be. So yeah, that's what we came up with today. So the next week or so, we'll try and get this thing in and have some fun with that. Cool. In the meantime, guys, Discord, if you want to come and chat. And there's also, if you enjoy the stream and want to support the channel, you can get access to the code to run on your own local machine and support the channel in the meantime. But yeah, thank you for everyone who's supporting the channel and coming by. I appreciate you all. Hope you have a good start to your weekend. I'll be on Sunday, 7:30 p.m. GMT +1, and that'll be the same for Tuesday and Thursday next week, and also Friday next week at 2 p.m. Cool. In the meantime, guys, have a good one, and I'll hopefully see you very soon. All right. No problem, Matrix. No problem, sir. But yeah, God bless you all. Have a good one. I'll see you all very soon. Bye-bye.